Hi everybody, I am going to rework the Intro R assignment from my structural equation modeling class because it has been a year and I've learned new tricks, and so we'll see how much of this overlaps with last year's assignment, but both ways are correct. Remember, the rule in R is not can you do it, it's how many different ways can you do it. So I cut and pasted the assignment here into RStudio, and I'm just going to comment out the lines and say what I'm doing. So the first thing you want to do is create the R script file. So I have this one labeled Untitled over here. So I'm going to do File, Save As. It's grumpy with me because I have all these extra codes in here. It will not normally ask you this. Okay. And I'm just going to stick this in here. So one intro R worked. And so that's all you have to do to create an R script file, is save your file. If you didn't have one open already, you can do the little plus symbol. Make sure you pick R script. If you accidentally pick text file, you'll see that you don't have any options over here. So if this over here is blank versus this where it has run and source, you've got the wrong kind of file open and it will not run. So be sure you actually have the run command here, or the scripts will not show up down here in the console at the bottom. Alright, so the next thing to do is to make a vector of numbers. Okay. And we'll do first with the rep function. So with rep, what I can do, I'm going to call this vector 1, is repeat any number or combination of letters or any particular thing you want to repeat here. Let's repeat the number 5 because I like it. It's any number by how many times. So we're going to say repeat 5 10 times. And so what I've got when I run that line of code over here under vector 1 is 10 numbers and they're all 5s. If I wanted to use the sequence function, sequence requires the start point, so let's say 0, the end point 20, and then by what? So I could do by 1, and that would give me 0, 1, 2, 3. And so it gave me 21 numbers because I started at 0. Remember, 0 to 20 is actually 21 numbers. I could change that to be by 0.5s and get even more numbers. I could do it by hundreds. So as long as it's divisible. Let's see, include a concatenate. So let's make the C function. You'll use the C function a lot in this class, and anytime you're using R, really. It's a way to combine lots of things together. So let's see, I want to say, let's pick some random numbers here. Oop, not an extra comma there. One more here. And so concatenate works great if you're just wanting to type in a small set of numbers. If you have a large set of numbers, concatenate's not your best option. What you should do is import a data set. But if you have a smaller set of numbers, that's great. I could combine all these together as well. This isn't part of the assignment, just as an aside. And say I want to combine a 10 5s and then a sequence of 0 to 20 by 1s, and then just even another set of numbers here. So you can do lots of different things, and you can use them together as well. So if I type vector 4 down here at the bottom, it'll show me that I have my 10 5s, my sequence of 1 through 20, and then those extra numbers are stuck on the end. This function is really great if you're working on, let's say, an ANOVA, or you need to add a column that is participant numbers, or if you're wanting to add, like, I need 20 of these, and then 20 of these, and then 20, like, kind of back and forth. This repetition and concatenating different repetitions really helps. Okay. All right, now let's do the length function. So this is numeric vectors is really what we did here. Okay. Oops, if I can spell length. So length doesn't work quite the way that you would think it does. Now on a vector, it's fairly easy because length will give you the number of items in whatever you're asking for. Now it's the number of items, not the number of lines necessarily. And so if I do length of each of these vectors, it's telling me how many items there are. But if we do a length of our matrix that we're going to make here in a second, you'll see that it doesn't quite work the way you think it does. So let's make that matrix, and then we'll come back to that point. So we want to make a matrix of at least 5 by 5 here. Okay. So my matrix is, I think the code says matrix. Okay. And so you could pull data in row, in column, by row. So here it popped up automatically the things that I can do, which is a really nice function in RStudio. So we're going to do 1 through 25. Number of rows is 5, number of columns is 5, and I want to do by row equals true. And so what that did was it created a matrix, and it did them by row. So 1 through 5 went in the first row, 6 through 10 went in the second row. If I had said by row equals false, that's the default, it would have gone down, 1 through 5 going down. But most of us think about data in a left to right sort of way, so going across just makes more sense. Now, let's try the length function again. And you'll see that it says there's 25 items. Okay, that makes sense. But that's not really the length of the matrix. There are 5 rows and 5 columns, but it told you there were 25 items. Okay. Hold on to that length thing again, because it's an important point that's going to matter. Maybe not so much for SEM, but just in general for R. We'll do that length thing again here in a minute. And that's not really part of the assignment, it's just a kind of a point I want to make. Okay. So for matrix, my matrix here, I want to pull out row 2, column 3. Okay, so I'm going to use the square brackets. And so remember that the brackets are row, comma, column. So I want to do 2, comma, 3. But if I click on the matrix over here and just look at it, I'm at row 2, number 3 should be 8 in our particular version of it. Okay. And so I get an 8. If I did my matrix, now here's a hint, it'll either pop up or you can hit tab. As long as it is a unique name, it will fill it in for you. If I did 3, comma 2, that gives me 12, because that's row 3, comma, column 2. So just remember, it's rows first, then columns. Okay. And that's the way that the apply function works as well. And so when we get into using apply, it's always rows first, then columns. So 1 and 2. Okay, so this one is incorrect. Okay. All right, now let's work with some real data sets or data frames. Okay. And so what we're going to do is look at the dataset USARS. Now, I could simply use the head function, and it will show me the dataset. But I probably should load that dataset. So I'm going to use data, USARS, and that is a dataset that is in R, and actually does not need the quotes. That's just something Studio did for me automatically. But that is a data set that's in base R that is sort of hidden in the background. I mean, clearly it's not over here in our environment window, but if I run that, what I'll get it here under values and it just says promise. I really don't know why it does that. I think it's just sort of like promise it's there. I don't know. But then if I run the head function, it'll pop up over here and be the real data set. And so head, what that does is it shows me the first 6 lines of any type of data set, vector, that sort of thing. So it just shows me the first 6 things. And then also over here under data, if you're thinking about data frames, it'll show you, here's the name of the data set, so to speak. It's not a data set, that's a different type of thing in R, but the way that most of us think about data, it's like, here's my data set, here are my columns. So here's the data frame, and then here are the names of the columns. So remember, to get to these different columns, you have to do something special because you can't just call it murder. If you just type in that word, it's like, I don't know what you're talking about. Even though you can clearly see that it's here, you need to tell it where to look first. So open this data frame, then here's the column name. Now here's the fun thing. I said we were going to hold on to the length function. Come on. Oops. There it goes. Now, if you were looking at this, there's 50 observations of 4 variables. So you might expect it to be 50 because there are 50 lines, or 200 because if you think about what it did for matrix, it told me there were 25 things. What it's really going to give you is 4. And so it's 50 observations or 50 rows, but there are 4 variables. So the length function works differently for vectors and matrices and lists than it does for data frames. So for data frames, it gives you the number of columns, effectively, the number of items, but it's considering each column an item, its own vector. And for lists, it gives you the number of list pieces in the list. So careful with length. It's a really great function, but it can not do what you expect it to do. So the next thing I want to do is calculate a summary. So that summary function gave me the min, the max, first and third quartiles, the middle quartile or the median, and the mean. The only thing I don't like about summary, because it's a great function, we're going to use it. It does lots of different things. It is smart, so it takes it gives you the summary appropriate for the item that you told it in. So we're going to use it a lot to give us a summary of our structural equation models. But for summaries of data sets and vectors, it does not give you standard deviation, which is just annoying. But that's easy to calculate as well. All right. So to import the data set, I'm going to do this 2 ways. I'm going to do this the working directory way first. So what I'm going to do is set a working directory. I'm not good with the path names. They're really long, and on my computer I have folders and folders. So what I do is I click Session, Set Working Directory, and then I pick Choose. So I'm going to find the directory I'm looking for that has the file I'm going to import, which is right here, this intro R1. Click Open. And then I just cut and paste this. Now the reason that I want to paste it into my script is so that later when I am running this code again, or let's say I'm working on this code with one of the graduate students, they're going to have their working directory, I have my working directory, but I don't have to find it every single time. It is saved in the code. And then we can just run those lines and not worry too much about, wait, where did I save that file again? So if I set my working directory, I can import my dataset. Now don't call it dataset because that's a command in R, although I am guilty of doing this as well. So let's call it my data or something. Oop. So I'm going to use the read.csv function because most of the data sets we're going to import are in CSV format. There are ways to import SPSS, but often it's easier if you're just doing comma delimited files. But if you're interested in importing from SPSS, I have some videos on how to use Mimisk because Mimisk works a lot better than Foreign. They're both libraries in R that will import data sets for you, but Mimisk tends to run. Foreign, they've stopped updating, so it's easier if you use Mimisk. All right, so in read.csv, I'm going to do quotes because it's a character, so it needs quotes around it, and then the name of the file. Is it capitalized? Let's see if that works. Okay, it was capitalized. So I just typed the name of the file in. I don't have to use all this crap up here. And now it's my data. So this data set has 34,000 lines, so not something we can type in, and 14 different variables. So this is from a project we worked on with a whole lot of data. So each participant's data is in here, and they each have like 200 rows. So it's about 600 participants. Now, the other way we can do this is the import dataset way. What you do over here is you click import dataset right here from local file. Yours might say from text file depending on how old your RStudio is. Click on the dataset you want to import. And if you're in this window, be sure you give it a name that makes sense. Don't start a dataset with a number. Okay? I will warn you in advance that is a bad idea. I've learned that one the hard way. Don't start it with a number, no spaces. So as much as you would love to make this as descriptive as possible, you can. Just remember, 1, you're going to have to type that, and 2, use dots or underscores. So no spaces and don't start with a number. It will let you do both, but it's a bad idea. Okay. So we're just going to call that my dataset. This heading function is pretty important. If you turn that off, if you see V1, V2, V3 here, and you have variable names, be sure that's clicked yes. Sometimes it catches that that's there, sometimes it doesn't, so just pay attention to that one. NA strings should be left as NA, like the rest of this should be left alone usually because R interprets it pretty good each time. That header is the one piece that sometimes it misses. Alright, let's click import. It will automatically view the data set when you do that. then I can copy this code right here and stick it in here. So if you import something, always copy the code from the bottom to the top. So make sure your import lines are in your code. That will also really help us troubleshoot your data, because then I can tell if you're importing the right data set, or just like kind of where you even started. Because oftentimes when students are troubleshooting, they're having problems, it's clear to me they've messed up the data set somewhere, just data screening, you accidentally typed the wrong thing. But then if you don't have the line about importing the data set, you're gonna have to like click all the buttons and remember the file is yourself. And this also makes it a little harder for me to troubleshoot where you went wrong. Now, this is the piece here that I think I've probably figured out easier ways to do, but we're going to recode all these left and right problems in this which hand column. So let me just even first look at what those values are. So I'm going to use the table function to look at what's happening in this which hand column. Because if you look over here in the environment window, under my data, which hand here is 12 levels. That really should be left, right, or NA. So it should have 2. Why does it have so many? Well, we let participants type it themselves, which is a bit of a bad idea as well, but we did. So remember that you can't just do this, because it doesn't know what that is. So I'm going to start by saying, okay, it's in my data set. I'm going to do the $ operator to get that column. And then it'll pop up all the different column names for you to use. At some point, people discover the attach function, which allows you to attach a data set and then use the column names just wherever willy-nilly. It does make things easier, but it also can cause you problems if you attach multiple data sets with column names that are very similar. And so I'm a squirrel and I'm very forgetful, so I always try not to use the attach function. When I first started R, it was like my best friend, and I've slowly moved away from it just because sometimes I don't remember what I have open and it's looking for. So if you've been taking Swirl or any of these other kind of help me learn packages, you can use that function. There's nothing wrong with it. It's just as a warning, at some point you want to move away from it just so you know which data set you're using every single time. It does make things a little faster to type, but on the other end, you may be using a column you aren't aware you're using. Yeah, just a warning. If you like attach, you should look up the with function. I find that one to be much better. All right, so looking at our table here of everything that's here, let's see, we've got this weird blank space here with a number 60 underneath it. That means that is literally coded as a space or blank. And so we'll have to do something with that because those probably should be NAs. Lowercase left, uppercase left, lowercase right, uppercase right, full case right, again lowercase right. So what's actually happening here? I'm not sure. We'll figure that out. Right hand, right left, right dot, and then with a cap letter. So there's a lot of things going on here that we should really fix. So let's start with the easiest ones. And there's a couple of different ways to do this, and they're all equally blah. So in the original one, what I did was I used the brain fart, the matrix format, sorry, I had a moment there, and sort of forced and looked for each one and coded them as left and then right. This way is fine, but it is a bit tedious. So let me show you some other ways that we can do this that I've learned since then, which is the factor command. So in the original video, it talks about doing each one of these things, and it also talks about subset, which we're going to do in here in just a second. And it doesn't hurt you to know if I look for things in rows and then only pick this column, but there are slightly easier ways to do that, to do what we're about to do. So first thing we're going to do, and it's going to be mad at us for doing this, but that's okay, it'll be fine, is I'm just going to save this as a second data set, because if I screw it up, I can reset it. So now I have a second data set of the same size. Oh, I called it my data set. Whatever. So now we've got 3 of them, but that's fine. And this is the one I want to fix. So we're going to fix my data set 2. And what column do we want to fix? Well, we want to fix the which hand column. Okay. Now, we're going to use the factor command. And we want to factor the which hand column. Okay. And what I want to do in the factor command is tell it what levels do I want to end up with. Or what are the current levels in the data set? Actually, I'm sorry, I said that wrong. So what are the current levels that we have in the data? Well, there's a bunch of stuff here. So how do I know how these are actually spelled? Well, I've got the table column here. I think there's also a levels column. So what I can do, or not column, function, is just type in levels down here. Okay. And this is not in the notes anywhere. It's just kind of a, hey, by the way, this is an option. And now I can see how they're actually typed. And that's really useful because in the table command I can tell that something's gone wrong because the word right is here and the word right. And it does not normally do that. It doesn't like you to have the same name of levels, as you'll see. But here are what all the levels actually are and how they're spelled. And look at this here. That's the problem that we're having, is it has this weird space. So what I'm going to do is actually can copy this here and paste it in here. Now, R will not like this format very much, so I'm going to just kind of clean it up. Put commas in here. And you can hit enter as long as the line ends with something it knows that there's still more coming. So I've got commas at the end of each line. And I'll talk a lot this semester about stacking your code because it does make it much easier to read and troubleshoot. Plus, you can only make this window so big. Oop. If I can hit comma, good gracious. So this closes this thing here. So those are the levels that we currently have. Okay, and I've got it in a C function because I have more than one. I'm gonna hit comma, I hit enter again. So you'll notice, let me make this a little bigger here, that what happened was it's stacking the commands for factor here, but all the pieces here for the C function in a separate tab. So it will tab over, if you've done any kind of programming before, they talk about tabbing your code to make it look pretty, well, it also just helps with understanding what's going on. So now I'm expecting something else as part of factor. What we're going to do is give it labels. Now you have to have the same number of labels as you do levels. So the first label I'm going to give it here is NA, because this little spacey thing here is actually a missing value. So I want to get rid of that thing and make it NA. And you'll see that NA came up in blue, which means it's a special function. Okay, so that means it's not available. And then I want to code this lowercase left to uppercase left, this capitalized left to left. So those are the first 3. And then I want to do right, right. Oops. I forgot to close my right there. And right. I know this right is technically correct already, so this one is the way I want it, but don't leave it out because levels and labels here for the factor command need the same number of pieces in each one. So I'm going to do right, more right, more right. Okay. Right, left, I guess we could put in as ambidextrous. That may be spelled correctly. Maybe not. And then this one is right. And with a cap letter, I have no idea what that means, so I'm going to code that as NA. So we're going to delete 2 of these levels basically, and then code all the rest of them as left or right. And then our ambidextrous line, which don't trust the spelling on that. Now, I will warn you that it is not going to like this very much because it doesn't like it when you duplicate levels, but it'll let you do it. Okay, so it gave me a little like grump grump. Now if I run my levels again, you'll see what's happened is it's made each one, it still has 12 levels over here. Which hand? It still has 12 levels, but it did fix them so they're all spelled correctly. And then the super neat command that I've learned about recently is drop levels. And this will drop duplicates. So before I do that, let me show you what it looks like. So we've got the levels command, but I can also do the table command to look at how many participants are in each one. So I've got like 6 students in most of these problem children one. Let's do drop levels. Okay. Now, that didn't do anything. So here's a rule. If it prints out, it does not actually save. So let me save that one. Okay. So just warning, if it prints out a bunch of stuff at the bottom, it probably didn't save for you. It gave me that same like grump, grump, grump. But now you'll see that which hand has 3 levels. So if I run this levels thing again, I've got right, left, and ambidextrous. If I run my table, it actually has combined them all. So the original table, if I scroll up past all this crap that I ran, good gracious, all 30 bazillion lines on it. Hold on, let me just do this. The original table looks like this. Right? The new table looks like this. So it's just combined all of those different ones together. Okay. There's probably a better way to do that than using factor and drop levels. But factor and drop levels works, so meh. You know, if I ran this again, nothing would happen to it really because it already has dropped the levels. The other thing you'll notice is that the NAs have gone away. The table command does not show you NAs, so those have just kind of become NAs. If I ran the summary of that piece, I can see the NAs. So summary on a factored variable shows you NAs, table does not. Just kind of a warning. Alright, so we'll make a summary of the overall data set now. And so you'll see I have some different NAs. So here's that summary again, just bigger form with all the other variables as well. Now, with the way I just showed you how to do this with drop levels and factor, this way of doing it where you do the column name, comma, row, comma, column, good gracious. There's nothing wrong with that. But what that let me do was it's a little faster than doing each line separately. Maybe I can cut and paste kind of a little quicker. It also allows me to kind of do them all at once. And then I don't have to quite remember all the rules for these different things. There was another good reason why you should do it this way instead of the other way, but I've forgotten it now, so I guess it's not important. Alright, we're going to exclude all of our data set, all of our missing values. So I'm going to call this no miss or no missing. Okay, na.omit is a great function that allows you to omit all missing values. So any participant with at least one missing value. Now this is not necessarily the best command to use if you're running multiple hypotheses because it will delete everyone with one missing value, and if you have like just a couple of missing spots here and there and you want to fill them in, they're all gone. The other thing is if, like, let's say they're missing the important component for hypothesis 1 but not hypothesis 2, and you want to leave them in for hypothesis 2, they're gone. Okay. But if you're wanting to just quick delete all the missing values because this is an example demo, na.omit is great. Oh, that's the reason. Okay, so the other problem that you'll have sometimes when you're using these sorts of commands where you have the search in row, give me this column sort of thing, it will work, but every once in a while you'll get this NA error. Column is not subsettable, and so that matrix format with the square brackets when you're using sort of subsetting rules doesn't always work if you have NAs already. And so that's one reason why subset is, I'm not sorry, that's the word I'm looking for here. Factor is a great command is because it can handle NAs, whereas this code here sometimes will get very grumpy with you if you're trying to search through things because an NA is not true or false. And so this code only really works pretty well when the columns have real values that it can code as true and false, whereas this factor stuff works better if you have NAs. That was the thing I was trying to remember. Okay, so if you get matrix is not subsettable or data frame is not subsettable, one, send me an email and I'll help you work it out, but that is maybe wise because the type of code you're trying to use just will not run that particular thing. So you may not be messing up the code in your understanding, it may just be that R will not do that for you. Okay. All right, so NA omit, we're going to get rid of all those NAs. So if I look at my data set 2, so I have 33,000, and I look at my no missing, I have 33, so it dropped about 200 lines of people that had at least one missing value. If I want to create a data set with only left-handed participants, so what I could do is subset. The subset function is your best friend. Which hand equal left. And so anytime you do that, you always want to look and make sure that the values over here are not 0 observations. Okay, so that appears to have worked. Now let's try this thing. Okay. So one thing I had done before is I had tried that matrix command. So let's do my data set 2, square brackets, and I want to pull from which hand, where it equals left. If I can spell left, you would think I would. And give me all columns back. Okay, so that's this command over here where I'm looking within rows and I want to find the rows that are left and give me all columns. Okay. And so what did that do? Different than subset. So check out the differences here. So lefties 1 has 3,900, lefties 2 has 4,000. There aren't more lefties randomly. So let's take a summary of lefties. Okay. And what it's done under which hand here is pulled just left from it with the subset command. I look at the second one, it's pulled left and the NAs. So subset excludes the NAs. Using the square bracket codes includes the NAs. Okay, so they work a little differently. Now I want to do a correlation table of these variables. So there's a couple ways to do this. So I could do core for correlation. I want to take lefties. We'll leave out the NAs so we don't have to deal with them. I could do the C function of all these different ones. So I can use column names in this. You can't always do this. Oops, wrong button. Okay, so if you highlight them and hit shift quotes, it will automatically put quotes around them. They do need commas. And then we'd probably want to do use equals pairwise complete dot obs just in case we do have some missing data. So that's one way I could do it. Okay. And it will create me a nice pretty correlation table of just those columns. The other way you can do it I'm going to use my same code here, is figure out what column numbers those are. So if your data set has a small number of columns, is you can use the names function and just count them. Okay. So I would want, let's see, we did left, right switch, so we're here, so this is 6 here, that one's 6, 7, 8, 9, 10, 11, and 12. So I want to do columns 8 through 12. Now put that in the columns section and not the rows, right? So both of these blank rows, give me all rows, these columns. And that'll do the same thing. Okay. So I could use the numbers or the words, either way. All right, so our bonus here, which really was a bonus more last year when I had students that had never seen R, but in this particular semester we've got like half and half. We're going to run this regression, so I'm just going to copy it. And I need to save it. So I'm going to save it as output. So I've got my linear model where rating is approximated by finger switch. Data equals lefties. I'm gonna run that. So that's going to save a regression where finger switches are predicting their ratings. So I've saved that output. And I only want to pull the slope. So this is dealing with lists. And lists are their own monkey sometimes, but let's pull this way. I only want to pull the slope from the coefficients. Okay. So here under output, if I look at the options, I have coefficients, residuals, effects, rank, fitted values, assign, QR scores, and then you'll see within each one there's a list and a list. So sometimes we have lists within lists within lists within vectors, and so you have to figure out how to kind of get at these things. So one thing I can do is do output $coefficients, and that gives me both of them. Okay. And so if I just want the slope, okay, there's also another command that's coif output, okay, and that gives me both as well. And I only know that because that is something we're going to use in our SEM code. So more than one way to skin a cat here. Now let's see if I want to get just finger switch. It's very tempting to try this. So keep using that $sign thing. And what's weird is sometimes that works, and sometimes it doesn't. And this particular one it gave me is invalid for atomic vectors, because this part here is not a data frame in a data frame. This is a vector in a data frame, so this doesn't work. Okay. And so that's why I find it important at the beginning of the semester to really explain the difference between lists and vectors and data frames. It's because sometimes it helps with the errors. So you can't do this sort of triple $sign thing because it's not a data frame and it's not a column in a column. It is a column of data that happens to have two pieces in it. So what I can do instead is treat it, coefficients, right, with my square bracket code. Okay. Now I don't have any commas because it's only two pieces. So let me run this again. So see, it's only two pieces. This is a named vector, or here a named number, if you will. So you can see right here what type of thing it is. So it doesn't have any rows or columns. It's a vector of data. It's just one row or one column. So I could say, give me the finger switch out of here, and that'll give me the only one. Or I can do output coefficients. So give me item 2. Okay. Now if you tried to do the wrong thing, so if I did 1, I'd see, oh, I did the intercept, that's the wrong one. I wanted just the slope. If you tried to do 3, it would tell you like, no, there's nothing in 3. Okay, so item 2. So understanding that is a output is a list. In that list is a vector named coefficients. So I can do this here to pull the entire vector. Now if I want to pull just one of these, this is a named number, so I can use the vector command here with the brackets to pull just the one piece by name or by number. And so one of the hardest things I think in R to learn when you're first starting is really those differences between the data frames and vectors and numbers and named numbers and all these sorts of things, and how to get the one piece you're looking for. But the more you practice, the better you get at it. The other thing too to remember is sometimes you can use the numbers in the square brackets, and sometimes you can use the words, and sometimes you can't use words. More often is the one that you won't be able to use. So it'll give you an error, usually in a similar form to this atomic vector one. It'll tell you something like not subsettable or not. I wish sometimes it would say you can't do that. Because it might be a little easier to search, because operator is valid for atomic vectors is an unfortunate thing to Google because there are lots of different reasons why you might get that error. But always feel free to ask questions on the Facebook page. You'll get answers, I think, maybe pretty quick, because we've got some people who have done a lot of this and feel pretty good about it, or send me an email and ask, but be sure to include your code that you're having problems with. Okay. So that is the first intro R assignment with a lot of explanation on how that answer is different from last year. Both answers are correct, you just have to complete it.